Hey guys, my name is Leo. I'm an engineer here at RoboFlow, and as Jacob alluded to, I work a little bit on OCR, optical character recognition, which is getting text out of images. So before we get started too far, um, I want to show off a little script that shows like where we are at right now in development of like using OCR and what it looks like when you're using OCR right now. So this is a notebook that we used to have on one of the blogs that I wrote of detecting doing optical character recognition on video for different like cargo use cases. So this is the blog. So what this script accomplishes is you can use optical character recognition and build consensus on which containers have what ID based on like what's showing up here. And you're able to read those texts and um, parse it and then assign those to individual tracking objects. So a little about so today we're gonna go over like what is OCR? Like what do you do with it? What is it and what can you get out of it? We're gonna compare some OCR models and some of like the methodology that we use to determine which model is actually best and show how you can compare OCR models yourself. So what is OCR? Like similar to how we use our eyes and learn to read, OCR is like a type of computer vision task that can recognize and extract words using vision. So if you've seen like license plate readers, if you've seen use cases where you like on the new iPhones, you can use like a scan text feature to extract images out of your camera and just paste that in. That's all OCR. And generally, there are two types of OCR that exists. There's like traditional OCR, which you turns it detects letters and object and characters and turns them into little 0, 1 bytes, which you can then parse into letters. And it's somewhat of a good approach for before machine learning came up. Um, but it also required a little bit of hard coding the letters to like see if it's this shape then it's an A, if it's this shape then it's a B, and it didn't allow for much flexibility in terms of new fonts that came up, new environments that came up. Like it works in a pretty sterile environment, but in the real world, it isn't as effective. And now we get into this age of machine learning models doing optical character recognition, where you can get where you can send in images and it'll extract in text for you. So what are the best OCR models? We compared and benchmarked some of like the OCR models that are out there. We focused on several key factors: speed, accuracy, and cost. And so the models that exist, we've generally found that these were mostly the ones that were best in their like the field that's out there. And so you can see here like the average accuracy of the models that are performing here. We see that a lot of the machine learning based OCR models like Easy OCR, Gemini, which is a large multimodal model by Google, Cloud, which is also a multimodal model, GPT-4, Gemini 1.5, and IDEFIX 2, which is a another vision language model by Hugging Face. Those perform usually well, and some of like the traditional approaches to OCR, like Tesseract, perform poorly. This is because we test our OCR on use cases that we see mostly from customers, which are like in the wild focused OCR, which is what we call scene OCR. And so these are like you can see which models perform best based on like medium speed efficiency, which is accuracy per elapsed second. We also have median cost efficiency where IDFX2 and Easy OCR perform really well. And so the answer is to the question what the best OCR model is it depends. It depends on the metrics that you're trying to align for. If you're looking for the cheapest OCR models, that might not particularly be the fastest or the best. It depends on specific images and it depends on specific use cases. And so what you can do here is you can compare different OCR models that exist. This is in workflows or new like visual-based product for building out computer vision pipelines. And what you can do is these two models, TROCR and Doctor, are in inference now, but GCP Vision, MathPix, and EasyOCR are new ones that we're adding soon. So what you can do is you can have an image, you can line up several different models, and then you can send it into the OCR consensus block and get an output. So what it will do there is it will send in all the models that is listed and try to build consensus. That's what's happening in this the video that I showed earlier of different containers and trying to determine what the actual ID is based on different attempts of identifying the text. And um, you can see it's pretty lengthy code, but what Workflows does is it makes it all visual and really seamless. And so you can see here that the consensus block over here built saw that, hey, these 1, 2, 3 models said this image here was this text, and it decided that, yeah, this is what it says, instead of TROCR, which got this wrong, because TROCR is generally like a one-line text model, but it can ignore some of the mistakes and pitfalls that some of the OCR models make while trying to get the best of like each model and what they're good at. And so the question becomes, how do I use OCR? And there's several different ways to use OCR. Like I mentioned here, you can use the optical character recognition or text recognition block in workflows here. And you can also use it in the inference SDK. Um, you can use it through the inference SDK, or you can have endpoint set up. You can have your own server. You can just call it onto your local device if that's what you want. And what RoboFlow is trying to do is we try to make it as easy as possible to be able to perform optical character recognition and other computer vision tasks on your devices. And so that is mostly it. And yeah, you can throw in other images that you have in here. When we get to our Q&A section, we can talk through like um, we can try to throw in images in here and see which ones perform best. And this OCR consensus block is also not in production workflows yet. But what you can do, what I did earlier this week was create this model myself, create this block by myself. The way you can do this is we also encourage other people to make blocks as they see fit themselves. But here, you can add a file within our inference package. This is our inference. This is pulled directly from our inference GitHub, and you can add a model block file into one of these folders here. And it looks a bit overwhelming when you first look at it, but you can add in different features from different blocks and write out logic and have it all appear on your web user interface. This is running on my local machine. You can also use it via hosted API dedicated deployment or other hosted servers, but um, in summary, it makes it RoboFlow just trying to make it really easy to build these workflows out, and you can write this custom logic to see if it's beneficial for you.